Hi, this is Prem Kumar, Assistant Professor at Department of Computer Science, Tirthangal Nodar College. Today, I'm going to discuss about the important topics which covers under the subject Introductions to the Data Science. So, let we see what is mean by the data science and what are the applications we are using in the applications in the data science. So, so we know what is meant by data science. It was an application which was widely used in various diverse fields. Here are some of the key areas where the data science is making a significant impact. So when you take a healthcare sector where it is used to predict the analytics and drugs discovery, personalized medicines, and also for the operational efficiency. So when you take a predictive analysis, it was early detection of the diseases using the patient's data, such as predicting a cancer risk for or and a heart diseases. So when you take a drug discovery category, here the accelerating a drug development using a machine learning to analyze molecular structures. And in the case of personalization medicine, the tailoring treatments based on a genetic and informations and the patient's history. But then the operational efficiency means here the optimizing the hospital overflow, resource allocations, and the reducing patients' waiting time. That is generally based on the time. And in the case of the financial sectors, where the fraud detections can be obtained, and algorithmic trading is going to be obtained, and risk assessment, and finally the customer segmentations. When you take about the fraud detection category, here it is used to identify the unusual patterns in transactions to detect and prevent the frauds. So this is the point we're going to see in that. And as per the next one, the algorithmic trading, in this, the user-driven data strategies to execute the trades at the optimal times. In the case of risk assessment, evaluating the the credit worthiness for loans and insurance premises using the predictive method models. The last one, that is customer segmentation, the analyzing the spending behavior to offer the personalized financial products. So this is the two applications, and the next is we're going to see the data science where the retail and the e-commerce places. In the case of e-commerce and retail, we have the four different places, that is the recommendation systems. So it was giving the suggestions for the products based on the customer feedbacks as well as the preference and the past behavior activities of users, consumers. And the next one is the industrial management. In the case of inventory management, here using demand forecasting to optimize stock levels and reduce waste. So in the case of the customer sentiment analysis, the analyzing reviews and the feedback to improve the products as well as the services. The demanding pricing is nothing but so you can able to go for dynamic adjustments in the real time based as well as the competitions on the other factors. And the next one is the next area what we're going to see is the transportation and the logistics. When you take this, so here we're going to optimize the routes and we're going to protect the maintenance, productivity maintenance, and the demand forecasting and the self-driven technologies. When you take this, the first route optimization, which tells about the improving delivery routes to reduce the cost as well as the traveling time by using the data science concepts. And the applications which also relate with the predictive maintenance, that is the monitoring the vehicles and the machineries to predict and prevent the failures. So by monitoring the vehicles and the machineries, will continuously able to find out if there is any faults or failures occurs while it was in under maintenance, or also we can say it is an under monitoring process. So in simple term, we can also say it is an reviewing the maintenance process. And the next one is demand forecasting. So demand forecasting is nothing but it is telling about we are optimizing the fleet deployment for the public transport or the ride sharing services. Then the fourth one is the self-driving technology, so enabling the automobiles, the autonomous vehicles through a real-time data analysis. So which is going to relate with the real-time data analytics. And the next one is in the field of education. It was widely used in the field of education. That is nothing but you can personalize your learning process, you can improve the students' performance analysis, and you can also go for the curriculum development and the resource allocations. So in the case of personalized learning, the adapting content to the needs of the individual students through the adaptive learning systems. Okay, so you can improve the individual students of the personalized method by using the adaptive learning system. Then the second one is students' performance analysis. It was going to identify the risk of the students and where we can able to improve the students' performance and the outcomes. And the next one is the curriculum developments. So in order to refine and define the newer upgradations of the syllabuses as well as the teaching strategies. When you go for the resource allocation, here we're going to optimizing the budgets and the staffing for the schools. So the number of staffs and the students who are going to involve in this. For that, we are going to optimizing the budget and the staffing for the schools, which was comes under the resource allocation. Then in the field of agriculture, so we can able to do something like the precise farming and the crop yielding predictions and supply chain management and the livestock monitoring. So when you take a precise farming, which was telling us to the data from sensor and the drones to optimize the irrigation. So we can able to easily monitor as well as precisely we can optimizing the irrigations, fertilization, and we can also go for the pest controls. And in the case of crop yielding predictions, we can able to estimate the yields based on the weathers, soil, and also for the historical data. And the next one, we have a supply chain management. It is going to tell you about the perishable goods, which is going to improve for an logistics controls. And the next one is the livestock monitoring. So here it was analyzing the animal health and the productivity data. And the next one we can able to see that is the transportation logistics. So where we can able to go for the route optimization and the traffic managements and autonomous vehicles, fleet managements. So the route management and the optimization is going to talk about it improves the delivering efficiency for the logistic companies, and the traffic management is telling you about the predicting and the reducing the congestions using the real-time data traffics. So we can able to reduce the congestions as for the real-time data traffics in the case of by managing the traffics. And in the case of autonomous vehicles, here we're going to use the advanced data processing methods and the AI concept for a self-driving cars through this autonomous vehicle concepts by using the data sciences. And in the case of fleet management, so in the case of we'll be using the Air Force as well as the passenger flights. So it is been keep on monitoring and optimizing the vehicles using the usages as well as the maintenance. This is going to be discussed under the fleet management. Then the next one is the energy, the demand forecasting, the predicting energy, the usage patterns to obtain the generations as well as the distribution process is being discussed in the demand forecasting. And in the case of the smart grids, so will be most of the thing we will be using the grid reliability using the real time data, etc. The renewable energy optimization. So it was for an forecasting solar and the wind energy production areas. And the equipment monitoring, it is telling you about the predicting a failure in the power plants and the distribution systems. So this is the place where we can able to see the data science concepts in the energies. Next, we'll see about the issues. So whatever the application, whatever the technology we have in a computer field and the technology oriented hardware, it may be hardware or software upgradations, there will be definitely we can able to come to know that there will be an advantages as well as the disadvantages. When you talk about the issues in the data sciences as well as the security, it was a critical concern for an individuals or a business and a governments as breaches and the vulnerabilities can have the severe consequences. So we have that. We'll be seeing about one by one what are the data security issues we have it in the case of the data science. When you talk about the data breaches, here the unauthorized access to the sensitive data such as the financial informations, personal identifications, or the intellectual property where the data is going to be accessed unauthorizedly without knowing. So this is, we say it is a data breaches. And the next one in under the data breaches, so often caused by hacking, phishing technology, as well as the attacks or the insider threats. So this can also be a part of the data breaches, and it can lead to identify the thefts, the financial losses, and the reputational damages. So this is what we have in the case of data breaches. When you talk about the malware and the ransomware, so these are the mainly used attacks can be we can discuss in the case of the network field. So when you see this is in the case of the first one, that is the malware. This is a software. It is designed to harm or exploit or the otherwise the compromise the devices or data that is what the thing is. So it was like in a example. So we can say like virus attacks, worms inside the systems, the spyware. So they will keep on monitoring the activities by the other person, that by the unauthorized users. This is under the spyware. So this can also be possible in the case of the data security issues we have. In the case of ransomware, it was a type of malware that encrypts the data and demands payment for this releases. So what happened is once they capture the user system, they used to encrypt all the data, whatever they have it in the system. At one particular point, they come to know that it was encrypted, and when you are trying to access the people who wants to decrypt the data, so they will demand a payment for their related issues. Okay, so this is what the major point we can able to see in the case of the data security issues. And not only this, we have the another thing, that is insider threats. The insider threats is nothing but the employers, the contractors, or the other insiders intentionally or unintentionally exposing the sensitive data. They are going to reveal the data through their, so employees data, contractor data is going to be revealed by themselves. Maybe they intentionally are, maybe knowing or unknowingly, they are exposing the sensitive data. And the other point, what we have here, this the often due to lack of awareness, negligence, and the malicious intents. So this is also we call as an insider. So what is general? We are saying into the concept of insider threats. So there will be a person inside the organization or in a institution. They're going to intentionally they're going to disclose the sensitive data to the others. So it was difficult to detect and also compare to the external threats. So if it is something happening outside, we can able to identify and we can restrict them. But if there is an insider attack will be there, so it was very tedious to find out, and it was also too difficult to compare it with the external threats. When you take a next one, that is weak authentication and authorization, that is nothing but as a weak users as well as the reused passwords and the inadequate multi-factor authentication mechanisms. So when it was keep on asking the multi-factor authentication, what happens is we can able to restrict the we can able to restrict the data accessing by using multi-factor authentication. At one particular point, it was reused as well as it is going to be weakened. So mostly the many factors. So we should be very confident and very conscious that whether we have been under the multi-factor authentication, and we should be very clear in that what was the username and the password we have used for that multiple authentication. If you fail to give a right answers to the multiple factor authentication, it's totally not allows the users to fetch the data as well as accessing the data. So it is also the one of the major fact that so we can able to do, that is we can able to always the right factors, that is in order to avoid the weak authentication as well as the authorization. So the best example what we can go is the multi-factor analysis, that is authentication or authorization will be the best example, so that the users other than the users, no one can able to access this. Okay, that is the unauthorized access to the systems and the data due to the poor identity verification process. Okay, so the next one is the phishing and the social engineering. Here, the attackers manipulates the individuals into the sensitive informations are granting access to their systems, often delivering via an email, phone calls, and any fake websites has been used for spreading the unwanted information as well as phishing the social engineering. And the next one, that is, it was mostly increasingly sophisticated and difficult to detect. And in the case of cloud security issues, so misconfigured cloud storage leading to the data exposure and inadequate access controls or the encryptions for the data stored or the processed in the cloud. Then the shared responsibility for the security between the cloud service providers and the users. In the case of data integrity risk, the unauthorized alterations of the data, either accidentally or maliciously, which affects the reliability and accuracy of the information, which is critical in the areas like healthcare as well as the finance sectors. And the next one is the IoT area, that is, in the IoT devices often lacks the robust the security measures, creating the entry points for the cyber attacks and also for the potentials to compromise the connected systems and the sensitive data. So the next one, the next area where we can able to see this data security issues is that is lack of encryption. So if you are not maintaining the proper encryption standards or the methods to the sensitive data, it will entirely spoils your the data. It is makes it easier for the attackers to intercept and exploit the information if it is not encrypted properly. And the regulatory compliances, in the case of regulatory compliances, so we have something called the data protection laws like GDPR, HIPAA, and CPPAA can lead to a legal and the financial penalties, which ensures the compliances requires robust securities measures and the continuous monitoring. In the case of denial of services attacks, which overwhelming the systems with number of traffics and that disrupts the access and the operations so that the data can be diversion and tactics for more targeted attacks. Okay, then the last one what we have that is the third party and the simple that is supply chain risks. In the case of the security vulnerability, in the third party vendors and the partners can expose an organization's data. It will increase the risk due to the interconnected systems and the shared access. Next, the data loss and backup failure. It was also the major part in the case of the security issues. In the case of data security, the loss of critical data due to hardware failures and the accidental deletions are the insufficient backups. So, which is compromise the business continuity as well as the recovery process. In the case of advanced persistent threats, that is APTs, prolonged and the targeted attacks aimed at stealing the data are and other example basis. And the next one is that typically involves sophisticated techniques and well-funded advisory. And the last one that is we have it in the case of the security issues in the data science that is AI powered attacks, which is a machine learning and AI to identify the vulnerabilities or the launch attacks. The quantum computing risk that is it is the potential to break the current cryptographic algorithms, making the encryptions absolutely. Okay, so this the above the things whatever we have discussed, the different areas and different things that is addressed as the issues required as a combination of the robust technique measures and also for the regular training and the awareness process, which regulates the compliances and the proactive monitoring. The security strategies should evolve continuously to counteract new and emerging threats. And the next one is the data collection and the data pre-processing in the data science, which reveals the data collection and the pre-processing are the fundamental steps in any data science projects. Here, an overview for each and every cases. When you take a data collection process, the data collection involves gathering relevant information from the various sources for analysis. This is the crucial for the quality as well as the quantity of the data directly. So in the case of the methods involved in the data collection process is one is the primary data collection. Here, the survey and the questionnaires are the direct input from the users or the participants. In the case of interview, the gathering the qualitative data through the conversations. And the case of sensor data, the data collected using the IoT devices are the sensors. The next one, the secondary data collection, it is going to talk about the public data sets, wrapping, web scraping, and the APIs. That is, we can able to get the data sets from the open data platforms like from the online, and that is called the public data set. And the next one is the web scraping, extracting data from the websites using the tools or the scripts. Then the API, the collecting data via the public or private applications, program interfaces. So the real-time data streams, which is the data collection continuously from the source like the social medias, the financial markets, or the streaming devices. In the case of enterprise systems, the data from the internal systems such as CRM and ERP or the databases has been involved. What are the challenges we can able to see or we can able to find in the case of the data collection is the volume and the variety. So when you take about the volume and the variety, it's handling the large as well as the diverse data sets. So maximum number of data we can able to consider for the data collection. And in the case of data quality, so it should not be like an incomplete or noisy or outdated data to be taken it for an data collection process, which leads you to give you the improper results or an output. So when you take about an ethical concerns, the case of ethical concerns, ensuring the compliances with the data privacy, also for the privacy laws that is GDPR as well as the HIPAA. So next one is after the data collection, where the very next stage is we're going to see about the data pre-processing. When you take a data pre-processing, it was like once the data is collected, the pre-processing ensures it is clean, consistent, and ready for the analysis. After collecting the data from the various sources, it can be ensured that it should be clean, consistent, and ready for the analysis. When you go for the data pre-processing, here we have to go for the several steps to be taken over. So the first step, what we have that is a data cleaning. In the case of data cleaning, we'll have something called handling the missing values. So it which leads you to replace the missing values by using the impute missing values like mean, median, mode, or using algorithms. Then the next one is we're going to remove the records with the missing data if appropriately. And we're going to remove the outliers, that is, to detect and address the anomalies using the statistical methods or the visualization methods. And in case of dealing with the noise, so it removes the irrelevant or erroneous data. And also when you go for the data integration, that is when you are combining the data after the collection process, the combining data from the multiple sources into an unified data sets. We have to make it as an individual data set. So the addressing schema mismatches or the data duplications can be avoided. And the next one is the data reductions. So we're going to find out if there is any data is going to be duplicated. It has been removed by using this data reduction technology. And the next one is sampling, which reduces the data size while retaining its representativeness. After removing the duplication data and redundancy data, we have to go for the sampling process, which will reduces the data set size while retaining its representativeness. And in the case of data transformation, here the normalization, scaling a data to a specific range that is from 0 to 1, and the standardization which transforms the data to have a mean of 0 and the standard deviation of 1. And for the log transformation, handling the skewed data. And the next topic, what we have that is, we're going to see about data integration, the transformations in the data science. How the data is going to be integrated and the transformations. We have already discussed about data collection and the pre-processing. With that continuation, we're going to do the integration process, and whatever the data has been integrated, it is going to go for the transformation, that is it is particularly deals with the diverse data sources and formats. Okay, so which means the data integration is going to talk about, that is, its definition is the data integration involves the combining data from the multiple sources into a unified data sets, which enabling the comprehensive analysis and its insights. So the steps involved in the case of data integration is, first we need to identify the data and we go for the data extraction, and the next one is schema matching. So once we identify the data, we go for extracting the data which was meaningful data, and also it should be in a structured formats. Okay, and after that we can go for the matching process by identifying with the examples like customers ID, roll numbers, and the order ID, any other examples, whatever we are taking, we will be taking a unified name for the schema matching. And after data integration, we go for the cleaning process. The cleaning process is going to eliminate the duplicates and the missing values, and it is also going to ensure that the data accuracy as well as the reliability. When you go for the data merging, so after combining the techniques like joining concepts, as like we have inner, outer, left join, out join, left join, outer join, and right joins. Using these concepts, we're going to merge the collected data, and after the cleaning, we're going to go for the merging process. Once it was merged, we have a consolidated data with us. That meant again, consolidated data is going to be unified data sets, and in the data in the it can be stored in the data warehouse, and also data lakes or the centralized databases. So this is how we can go for the data consolidation. And what are the challenges we can able to find it in the case of data integrations are, one is the heterogeneity as well as the data quality, the scalability, and the real-time integrations. When you take about the heterogeneity, that is, we know that we'll be collecting the data from the different sources. So when we can also receive the different types of formats, structures, as well as the naming conversions. That will be the most difficult to process when you are going for the data integration. And after the heterogeneity, we go for the data quality. We can able to find some inconsistency as well as the inaccurate data across the sources. So which can be minimized by using the data cleaning process. And finally, we can go for the scalability, which is going to give you the large volume of data. From that, we're going to synchronize the data with the live systems, that is with the real-time integrations. And what are the tools we can able to see it in the case of data integrations is, they'll be using ETL tools, that is Talent, Informatica, as well as Apache, Nifi, and Alteryx. These are all the tools can be used. And also for the data warehousing, the Snowflakes, Amazon Shift, Google BigQueries. And in the case of programming libraries, most probably they'll be using Python, that is Pandas, and PyODBC, as well as the R languages. And after integration, we go for the transformation. In the transformation, it is going to do some conversion. What type of conversion it is going to do is, it is going to find the converting data into the suitable format or structures for the analysis. And it is also going to ensure that the capability with the machine learning algorithm as well as the visualization tools. So here we have some of the types for the data transformations by cleaning the data, data formatting, data normalization, and data standardization. When you take a data cleaning process, we know it is going to remove the data outliers and the irrelevant data from the collected data, and we're going to fill the data if it is any missing. And the next one, when you go for the formatting, it is being formatted using the standardized format, that is data formats, date formats, accuracy units. Everything is going to be checked before we go for the next stage. And in the case of data normalization, which is mainly used for to reduce the duplicate data as well as the different large variations between the values. And the data standardization, we can be used to transform the data by the means of zero and also the standard deviation of one. So common in algorithm sensitives to the scales, that is SVM as well as KNN, can be used for the data standardization. The importance of the data transformations is, which is going to tell you that it is going to enhance the data capabilities with analysis tools and the algorithms. So noise reduces as improves the model accuracy, and it also simplifies the data visualization and the interpretations. The tools which is used for the data transformations are for a library, that is Python library, Pandas, NumPy, and TPLYR. These are the libraries can be used for the data transmission, and also the ETL platform, that is Talent's Apache Spark has been used. In the case of cloud services, AWS Glow and Google Cloud Data Flows is being used for the tools in the case of data transformations. Okay, and in the case of the conclusion part, the data integration ensures the comprehensive, unified data sets, while the data transformations prepares the data for the signing, that is meaningful analysis, and altogether they form a crucial foundation for the successful data science projects. The next topic, what we have it is exploratory data analysis, that is EDA in the data science. So it is one of the critical steps in the case of data science flow work, which means it involves the analyzing the data sets to summarizing their main characteristics and often with an aid of the visualization techniques. So EDA helps the uncover patterns, spots, anomalies, test hypothesis, and the validation symptoms before building the predictive models. When you take the objectives of the EDA, you can say that we can understand the data structures by identifying the variables, data types, and the relationship between the features. And next one is detecting the outliers and the normalization, that is, find the unusual data points that may affect the model performance. And the next one, that is assess data quality, that is identify the missing, inconsistent, and or erroneous data. And after that, we have that is discovering the patterns and the trends, uncovered insights, and the relationships between the variables has been used. And the guideline feature selection, which is used to determine the features are relevant for the modeling. Then the formulated hypothesis here to develop the potential questions are the directions for the deeper analysis. Okay, this is about the exploratory. With this continuation, we'll have the EDA steps. So when you talk about this EDA, that is the first one, we're going to have the data summary. So the descriptive statistics says that use the measures like mean, median, mode, variance, and the standard deviations can be for the descriptive statistics. And the next one is after doing all the measure process, we go for the summarization and find out the critical variables which frequently counts. And the dimensionality talks about so how the checks the number of rows and columns the it is going to have like in a samples as well as the features. The next step, what we have that is data visualization. It is going to tell you about the univariate analysis, which explores the individual features and the tools which involves for this data visualizations is histograms, like shows the distributed of the numerical variables, and the box plot, which tells you about the highlights, medians, quartiles as well as the outliers. And the next one is bivariant analysis. This bivariant analysis is nothing but they explore the relationship between the two variables. That is the tools which is used to involve that is scatter plots and heat maps and the bar charts. So these are the tools can be used for the bivariant analysis in the case of data visualization. And the multivariant analysis, when we talk about the multivariant analysis, which examines the relationship involving more than two variables, that is pair plots as well as the parallel coordinates. When you take a pair plot, it is going to visualize the pairwise relationship. And in the case of parallel coordinates, which compares the multiple variables and go for the visualization process. And the third one is identifying missing and outlier data. We have discussed many times about the missing and outliers. So in the case of here, the missing data, using the visualizations like heat maps or the missingness plots, so addressing the missing values through the imputations as well as the removal process. The outlier, it talks about the box plots or the scatter plots to detect anomalies, decides whether to transform the cap or the exclude, whether we want to go for transformation or we want to exclude them. That is what we have in the case of identifying the missing and the outlier process. Then the next one is the feature relationships. When you talk about the feature relationships, we have that is correlation analysis as well as caution versus correlations. So when you talk about the correlation analysis, it is going to tell you that the relationship between the variables and the dimensionality reduction process. So when we have the comparison between the correlation and the cautions, it is going to tell you about the not implying causality. That is, the EDA helps forms hypothesis but does not confirms them. And the next one we have that is model development in data science. So in model development is a core process as well as a phase in the data science life cycles. It involves designing, buildings, testings, and fine-tuning machine learnings are statistical models to derive predictions, classifications, or the insights from the data. So we know generally the modeling means we can able to say it was in a designing as well as go for the giving an outline of a process or a model. So the key steps involved in the model developments is that is it is going to tell you that clearly state the problems to be solved, and also it is going to give you the target variables and the features to be identified, whether it is an independent variable or it may be a dependent variable. And the next one is data preparations. We have something called the feature selection, a feature engineering, data splitting, scaling, and normalization. When you go for the feature selections, we have to choose the most relevant features for the model. And after selecting the model, we have to create the new features along with the transformation variables and or encode the categorical data. So in the case of data splitting, splits the data sets into training, validations, and the testing sets. Okay, it should be like 70 is to 20 is to 10 or 80 is to 20 splits. The data is going to be splitted based on the validation as well as the testing along with the training process. The scaling and the normalization, it's talk about the features to improve the model performance for the algorithm sensitivity to the scales. Choose the model type, that is, select the appropriate model based on the problem types, that is, supervised learning as well as the unsupervised learning and also reinforcement learning. When you talk about the supervised learning, here the regression, that is linear regression, decision tree, random forest, gradient boosting methods, regression is being used, etc. And the case of classification, logistic regression, SPM, as well as the neural networks, etc., has been used for the supervised learning process. When we are going with an unsupervised learning, we have something called clustering, which means the k-means, DB scans, and the hierarchical cluster concept is being involved. And the next one is the reinforcement learning by using Q learning. Deep Q learning consists of the complexity, interoperability, and the data requirements of the models. Then the next one, that is the model training. Here, the training on the model based on the training data sets using the chosen algorithm. And the next one is optimizing hyperparameter like methods such as grid search as or a randomized search has been involved for the model training. And the next one is the model evaluation after what is the previous we have discussed about the training. Once the training gets over, we go for the evaluation process, whether it has been working properly or not. For that, we're going to validate or use the validation sets to evaluate the model performance and the we can prevent the outfittings. That is also we can say it is an overfitting. The common matrices we have something called the regression, classification, and the clustering. The methods is being used for either we can reduce the error or we can able to go for the performance. We can go for the evaluation for maintaining the uh, model evaluation process. Next one is the hyperparameter tuning. Here, this is used for to improve the performance. Purely, it is used for the performance. So the techniques which is being used under the hyperparameter tuning is we can go for grid searching, random searching, as well as the Bayesian optimizations. Okay. The next one we have that is model validation. In the model validation, we have used techniques like cross validations to ensure the robustness and the generalization. k-fold cross-validation, which splits the data into a k subsets, trains and tests the data models k times. And after go for various times testing, accesses model stability across different data sets. The next one, model testing. Here, the model is going to be tested on the separate test data sets, which was not used during the training as well as the validation process. And the next one is model deployment. Once every testing has been gets completed, we can go for the model deployments, which is deploy the trained model into the productivity environment for the real world use. Like we can take an example such as the cloud services like AWS, Azure, and Google Cloud or any local servers. Monitoring and maintenance here, the monitoring the model performance over time to detect drift or a changing in the data. And the next point we have that is we can able to update or retain the models as needed. The challenges what we have in the case of the model trained development is we can able to work it on the overfitting, underfitting, imbalanced data sets, and the feature correlations, and also for the computational resources. These are the places we can able to find the challenges in the case of the model development. The tools which is being used in the case of the model developments is programming libraries, that is Python as well as the R languages. And in the case of integration platforms, we can go for the Jupyter Notebook or Google Colab as well as Databricks. And visualization, definitely we can come over that. That is Matplotlib as well as the Seaborn and then Tableau. And the best practices can be used for the data modeling is we can go for simple start and multiple iteration has to be taken over. And we have to go for automated wherever possible. We can go for any evaluation process. And after evaluation, we can go for documenting the things based on the configuration results as well as the decision. And it has to be interoperability between the environment for identifying the any interceptables as well as the explanationable. And the last one is reproducibility, which used to say that the maintaining a reproducible workflow using tools like JIT as well as the machine level flow, okay, machine learning flow. The outcomes of the model developments are it is have a trained as well as the validated models that provides the actionable insights on the precision, a frameworks for the continuous learning and adoption in the a dynamic environment. The next topic what we have that is prediction and decision making in data sciences. So when you talk about the prediction decision making, so here the pivot goals of the data science are we're going to do the leverages data to forecast the outcomes, and while decision makings use these insights to select the optimal actions. So both the processes are integral to driving the data driven statistics across industries. That is, when you talk about the predictions in the data science, that is, it is going to tell you about how the prediction has been involved in the historical data and the statistical or the machine learning models to estimate the future outcomes are the unknown values. Next, the steps in prediction. We can go for defining the objectives, preparing the data, and select the models. So in the case of defining the objective, we have to identify the variables, targeted variables, and determine which regression we're going to use it for the classification problem. And after the objective, we go for data preparing by using cleaning, pre-processing, and transformation the data for the model capability and split the data into the training, validation, as well as the test set. So after that, we go for the model selection. That is either we go for a supervised learning or unsupervised learning or reinforcement training, whichever model it is suitable, we have to select. And after that, we go for training the models. So we have to use the historical data to learn the patterns as well as the relation, and we have to optimize the hyperparameters for the better performance. And after training the model, we go for the evaluation. This evaluation can be measured using the predictive accuracy using the matrices like MAE as well as RMSE, root mean square, as well as the other classification accuracy positions like recalls, F1 scores, as well as ROC, AUC concepts. Okay, the next one is deploy the model, and after evaluation, after training, after evaluation, next very next close step we have to follow, that is deployment. The deployment is it is going to implement the train model into the production environment for the real time or the batch predictions. The applications for the predictions are we can able to see that the healthcare will be the major role, and finance sectors is also, and retail and marketing. These are the place we can able to go for the predictions with the existing happens with the current things. And the decision making in the data science, it is also the important point we have to discuss. That is, it going to tell you about the insights derived from the data to choose actions that achieve the desired objectives, often under uncertainty. So we see what are the types of decision making approaches we have. One is we can go for descriptive analysis, predictive analysis, or prescriptive analysis. When you talk about the descriptive, it is going to be fully focused on understanding historical data to identify the patterns as well as the trends. Next one is we can say the predictive analysis, which uses the models to forecast the future outcomes. When you go for the prescriptive analysis, which recommends the actions based on the predictivity, insights, and optimization techniques. The steps involved in the case of decision makings are the frames the problems, which defines the decisions to be made and the objectives. And okay, next one is the gather insights, which analyze the data using EDA and modeling, and the evaluate options, which use the simulations and optimizations or the scenarios analysis to assess the alternatives. And finally, we go for decision making and monitoring the outcomes. In the case of decision making, we go for the best course of an action based to select it on the data driven insights. And the next one is monitor outcomes, which tracks the results of the decisions and refine the approaches if needed. Okay, then the next topic is the cross validation in the data science. When you talk about the cross validations in the data science, which means the cross validation, it is one of the statistical technique can be used for the data science to assess and performance the generalization ability of the machine learning models. And also it is going to tell you about data division process into a multiple subsets, and after the multiple subsets, it has been individually trained, and finally we come to integration process in an individual subset. Finally we go for the testing process. This process helps ensures that the model performance well on unseen data, minimizing overfitting and the underfittings. Okay, next we'll see about how and why the cross-cutting cross use we have to use for go for cross validations. So when you take a generalization check, it's going to ensure the model's ability to perform well on new or unseen data. And the case of model selections, which is going to tell you or keeps helps that they compare and select the best algorithms or hyperparameter configurations. Then the next one is data visualization utilization. It was efficiently uses the availability data by repeatedly training and testing the models on the different subjects. The last one is we can see about the reduced biases as well as the variances. So we can reduce the weights as well as the bias and the variance traits of in the model evaluations. So what are the types of cross validations we have? That is fold out methods we have, that is we're going to split the data sets into two different parts, training sets as well as the testing set, that is in the ratio of 70 is to 30 percentage. And what are the pros we have it in the case of fold out method is it was simple and quick, and the cons it is going to tell you about, that is the model performance can depends on the specific trained sets splits, and also it is inefficient for the small data sets. And in the case of k-fold cross validations, the process that splits the data into KKK equal sized folders, train the models on k minus 1, k minus 1, k minus 1 folds, and go for the remaining folds. This process is going to be repeated for each and every test set is going to be done. And the pros for this particular k-fold is it reduces the variance associations and also it works well on the small data sets. The cons is it was expensive for the larger data sets on the complex model. Then when you talk about the typical values for the KKK, that is the common values which going to be include in this that is 5 or 10. Uh, then the third method what we have that is stratified k-fold cross validation, that is, it is similar to the K4, but we can go for the proportional representations of targeted reserves as well as the classes. The pros under this stratified K-fold cross validations are ideal for the imbalanced data sets, and the cons is nothing but it is slightly more complex to implement it. And the next cross validation is leave out leave one out cross validation. That is, instead of KKK, we go for n minus 1, n minus 1, n minus 1 samples for training and one samples for testings, where the n is the total number of samples and repeat for all the n samples. The pros under this leave out cross leave one out cross validation is it uses the maximum data for training in each iterations and it is suitable for the small data sets. The cons under this is it was very computationally intensive for the large data sets. When you talk about the next one, that is leave a P out cross validations. Here, we're going to make a combinations of N as well as the P. That is N minus P, N minus P, N minus P samples, and the test is on the PPP samples. In the previous method, we have used total number of samples as N. Here, we're going to take it as N P for the total number of sample tests. So this sample test is going to be repeated for all possible combinations. And the pros for this is it was thorough evaluation of the entire models, and the cons under this is it is computationally infeasible for the larger data sets. Most probably, the previous whatever the cross validations we have discussed, it was going to tell you about that is it cannot suitable for the larger data sets. And when you take about the time series cross validation, it splits the data while preserving the time order based on no shuffling process and train on the past data sets and the test on the future data. So example that is train on data from the January to June and test only July, which means which we can able to go for the future as well as we taking the data from the past part. And the pros under this is maintains a temporary integrity and the cons the limited applicability to non-time series data. So we can able to take only for the based on the time. That is what they are telling limited applicability to non-time series data. Then the evaluation matrices in the cross validations are that is regression, that is we're going to find out the mean absolute value, that is error, and the next one is root mean square error and r square scores. So these are the regression metrics, as well as we can also go for the performance matrices can be used for the regression. And in the case of classification, what are the performance matrices can be used? That is, we can go for accuracy, precisions, recalls, and F1 scores, and ROC, AUC concepts. And the next one, that is multiple testing multiple parameters using grid search in data sciences. So what we can say about the grid search is the grid search is nothing but it is an hyperparameter optimization techniques used in data science and the machine learnings. It involves researching through a manually specified subsets of an hyperparameter of a model to determine whether the combinations that is to give you the best performance. Why use data grids? Why we have to go for data grids are nothing but it is talk about optimization, model performance, systematic explorations, applicable across algorithms. These are the three things we can see it in the case of grid searches. That is, it helps to find the best hyperparameter values for the maximum accuracy. And in the case of systematic exploration, it is give you the every possible combinations with the defined ranges and applicable across algorithms. The most machine learning algorithms requires the hyperparameters tunings. The next one, what is grid searching? In the case of grid searching, it was telling you that is the exhaustively search through a specified set of hyperparameters values, training and evaluating the models for the every combinations. And the goal of the grid search is it is to identify the hyperparameters values that yields the best model performance on the validations data. The steps for to perform the grid search is prepare the data, define the parameter grids, train the train and validate the models, and select the best hyperparameters. Either the key parameters used for the grid searches is estimator, param grid, and the CV, that is nothing but cross validation, and scoring, whether it may be talking about the performance like accuracy, precisions, recalls, and F1 scores. Thank you. Hope you can understand this session. We'll meet you on the next session. Thank you.